Graph the polar coordinate 4 root 2 7 pi over 4. Now this is a polar coordinate, and polar coordinates are in the form r theta. Now, when I were to graph this, and I'm going to make a rough draft over here just so we can kind of compare the two. Whenever you're looking at a polar coordinate, your magnitude is how far away from 0, 0 am I going to draw my dot. 4 root 2 is like 5 point something or 6 point something. 7 pi over 4 is the direction that I go if I were to start out at the positive x-axis and spin it counterclockwise. 7 pi over 4 is this direction right here. So me drawing a dot like 5 or 6 units away in the 7 pi over 4 direction is going to be somewhere down there. So I know my answer is going to be somewhere down here. Now I need to find it out. Rectangular coordinates are x, y coordinates. And when you first learn about unit circle, especially unit circle where the radius is not 1, you learn that x is going to equal r cos theta, and y is going to equal r sine theta. So now it's a matter of taking this information that you already know, plugging it into these two equations, and using unit circle information to figure out the rest. So x is going to equal r, which is 4 root 2, cos theta, which is 7 pi over 4. Okay, cos of 7 pi over 4 is root 2 over 2. So root 2 over 2. X is going to equal that. Okay, 4 over 2 is 2, and root 2 times root 2 is also 2, so x is going to equal 4. Okay, regular old 4, easy peasy lemon squeezy. I'm going to do the same exact thing with the same exact numbers, but now it's a sign. So 4 root 2 sine 7 pi over 4. The sine of 7 pi over 4 is negative root 2 over 2. So y is going to equal 4 times root 2 times negative root 2 over 2. 4 over 2 is 2, and 2 times root 2 times root 2 is the same as 2 times 2, which last time I checked is 4. So my rectangular coordinate is going to be the point 4, negative 4. So 4, negative 4 is going to be my dot. So my little prediction that I drew up here ended up being pretty accurate. Big surprise. I kind of knew that was going to happen. But what I didn't know is that the numbers would be so nice. But before I end the video, here's why the numbers are so nice. This is a perfect diagonal, which means if you were to cut, if you were to cut this guy into a perfect triangle, this would be a 45, 45, 90 triangle. You would be 4, you would be 4, which means you would be 4 root 2. So it kind of all ties back to everything that we've learned back in geometry and all that fun stuff. It never seems to go away.